Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
Okay, welcome back everyone. Very loud. So, we are thankfully back in our usual room, in our usual time and place, for the first time in this term, which is very nice to be in our normal place. Today we're going to be continuing on from last week and talking a bit about economic growth, in particular sort of production functions and how we might think about utilising those to investigate economic growth. And time permitting, I expect we will actually have time, but I've still called it time permitting just in case. Time permitting, we'll also talk a bit about unemployment towards the end of today. And we'll talk more about unemployment next week as well, a little bit more about unemployment next week. We're going to be talking about really focusing on modelling economic growth. And we're going to look at the not classical, but the traditional model, the usual model, which is our solo swan growth model. We'll talk about some policies that the government could think about for improving economic growth, particularly in light of what we've learned from our modelling. And then, as I say, time permitting, we'll talk a bit about unemployment as well. Okay, I will talk as well about the next assessment. The next piece of assessment that's due, which is due Tuesday of next week, Tuesday of the week after next, Tuesday of week 11, not Tuesday of next week, is the personal project. I've had some requests for this, so I have put up the boxes online, so if you've already finished, which I know some people have, but I expect most people haven't yet, you can put those up online. As with problem set 1, please submit it to the Turnitin box that corresponds to your student number. The boxes are slightly different this time, but please do try and submit to the box that corresponds to your student number. Just a few quick notes on the personal project. This applies particularly for those who are doing the micro version. Just as a show of hands, for the personal project, who's doing there's two versions, the microeconomic version and the macroeconomic version. Who's doing the microeconomic version? Who's doing the macroeconomic version? Couple. Who hasn't looked at the assignment yet? Those who are in that last group, I strongly encourage you to get started, particularly because a lot of it is look around you and decide from your observations what you want to talk about. And you want to have as much time as possible to be making those observations and deciding what you want to talk about. So, particularly for micro, the first point here is particularly for micro, you want to be using an anecdote from your own life. As I just said, you want to be looking around, at the world around you and looking and finding something that seems a bit unusual and talking about that. And so part of that is going to be what you saw, right? I went to the place and saw that this price was ridiculously high and had no idea what was going on and needed to find out why. And so that's what I'm talking about. Or this price was low, or I didn't understand why there were lots of this being sold but none of this being sold, or whatever it is that you found. So you have to include that anecdote from your own life to sort of bring together the project, to bring together the why it is that you're talking about this thing that you're talking about. Also vital, required for this assignment, both for micro and macro, is to use multiple topics from the course to discuss your issue. If your issue is about why the price is high, it's not enough just to say there's higher demand than I thought. Right? You might want to talk about market structure, or you might want to talk about some sort of market power, or you might want to talk about particular reasons why demand is higher than you might think, or what did I talk about before? Demand, supply, market structures are the three main things we've talked about. All of those you should talk, depending on what the problem is, you might want to talk about all of those or some of those. You might want to talk about some other things as well. I'm happy for you to bring in additional sort of low-level micro stuff as well if you want to talk about other things, other theories. You should be getting data, so you should be looking for data from around different places. That applies mainly to the macro section. For the macro section, data is really important. For the micro section, data is still useful. I've had a few people come to me in office hours and ask about this. The data we're looking for is not necessarily data to prove your point, but data to illustrate your point. So someone as part of their argument had to argue why Aldi was cheaper than Woolworths. That was part of their argument. It wasn't the only part of the argument, that was part of their argument. Now, you don't need data, you don't need a full data we fully analysed to demonstrate that Aldi is cheaper than Woolworths. But a couple of instances will be very useful here. You know, we looked at the price of good 1, 2, and 3 at Aldi versus Woolworths, and in each case, the price tends to be about 20% cheaper. So we'll take 20% cheaper as roughly the amount that Aldi is cheaper than Woolworths, or whatever it is that you're doing, right? A couple of illustrative examples from real-world data is very, very helpful to build your case for build your argument, right? It's better than saying, I think Aldi's cheaper than Woolworths. It's good to go out and say, I think Aldi's cheaper than Woolworths, and here are some examples. Right, it's not data per se. It doesn't prove your argument, but it illustrates. Any questions, comment? Actually, any quick questions on anything I've said so far? And I'll take questions on the assignment as a whole in a moment. But any questions on what I've said so far? Yes. The topic doesn't need to be brand new in the sense that we have 500 students in the course, so there's going to be some overlap. I suspect there'll be some overlap. But the topic shouldn't be, I looked online and read some articles and there was a news article about such and such, so I'll just copy the news article. Right? It should be something that ideally, should be something that you've personally noticed for the micro version. The macro version is a bit different. The macro version, you would also do that. It's less of a concern in the macro version of the assignment. Does that answer your question? Yeah. Have questions on what I've said so far? Again, I'll take questions on the question as a whole in a moment. Lovely. The last thing, I really don't like talking about this, but I feel like I am supposed to. So we need to worry about plagiarism a little bit here. If anything, things that are copied from a source and not cited I shouldn't actually call this plagiarism, I should call this poor academic practice, or potentially academic misconduct, or potentially plagiarism, depending on the degree to which things have been copied from a source and not directly cited. The reason I'm bringing this up now is that I had some issues in the problem set 1, where people were not quite clear with what needed to be cited. Anything that you copy, anything that you quote word for word from any source for any reason, you need to indicate that it's a quote. You need to directly cite the place where you got it from, which means an in-text citation, which means you put quote marks around the quote, you put an in-text citation at the end of the quote saying where you got this thing from. That might be in text, might be a footnote, but you put in a citation at that location saying where you got this object from. Some people had this for definitions, particularly in the problem set 1, and that's still not okay, right? If you're pulling a definition from a source, that's okay, but you need to quote the source. You need quote marks around what you said. You need an in-text reference. Additionally, you should be trying to avoid quoting anyway. If someone said something in a really nice way, then it's good to quote them. But basically, you should be pulling your own ideas or paraphrase, or if you're trying to define what economic growth is, you should give your own word definition of what economic growth is, rather than just pulling from the lecture slides or from the textbook, or from a textbook, or from wherever you draw from. The ANU has a plagiarism standard, which I've linked to here. Please do have a look. Yes?
James, in terms of referencing, so the footnote is suffice as opposed to going back to your reference?
Sorry, yes. The question was, do footnotes replace bibliographies? And the answer is no. Footnotes are a short form of this. So footnotes are, so if you don't have in-text citations, which is okay, you should have some really, but it's okay if you don't have any. Sorry, I'm going to start again. You must have a bibliography. You must have a bibliography at the end, which will have at minimum sort of 3 or 4 citations, but maybe up to 7 or 8, or maybe a bit more if you're doing a macro assignment potentially. I think I said on the assignment sheet, I don't care what citation method you use, as long as it's consistent and complete. So as long as it's, it all looks the same and in the same structure, and it gives me enough information to be able to find the sources. In-text citations don't replace that. In-text citations are, if you're quoting from somewhere, let's say quoting from the textbook, let's keep it easy. Quoting from the textbook, you'd have quote marks around it, you'd have a footnote that says, Acemoglu et al., microeconomics, or you actually say Acemoglu et al. 2017 as your footnote. And then in your bibliography, you would have the full list of things. You would say Acemoglu, I don't remember the other 2 authors, that's really bad. Acemoglu et al., 2017, economics, published by this person, the full bibliography entry. So no, they do not replace.
The examples that you've uploaded, casually written,
Yep.
acceptable as well, a bit more formal.
The examples I've given, you would argue, are pretty casually written. That's okay. The way they've written is fine. You can write a bit more formally if you like. It's up to you. I'm happy if it's a bit more formal. I don't want it to be like a full research paper level of formality. It should at least a little bit, because you are partially discussing what you saw and your own experience. So I do want a little bit of not fully formal, but I'm happy if they're more formal than what I've uploaded. It's fine. Question? No? Any other questions about the yes? The structure should be broadly, well, yes. The answer is, the question was, should the structure include introduction, body, conclusion? Yes, there should be an introduction section. There should be a conclusion section. It's not necessarily a strict essay form, because it's not a strict essay. But yes, introduction, which tells me what you're going to talk about, a big body which discusses it properly, and then a conclusion which reiterates what you talked about is expected, certainly. You might move you might put the observation, the real life observation, in the first body paragraph or in the introduction, depending on where you think it fits best. If it's a fairly long description of your observation, if your observation is wordy, you might make it the first body paragraph, rather than put it as part of the intro. If it's really just a single sentence, then maybe it's better off in the intro. It'll depend on circumstance. Any other questions? Yes. Pardon? I can't quite hear. Can you speak up a little bit? You must cite the source of your data. Yes. So if you just get data from a website, then you should cite the website. So things like Fred occasionally get their data from elsewhere. If that's the case, like from the World Bank, for example, if you're using Fred data and it's from the World Bank, then I don't mind which one you do, but you really should cite the World Bank, the original creator of the data. Is that your main concern? Yes. Okay. Sure. Ideally, you cite the World Bank report, but otherwise you cite the Fred data, and that's okay. That's very unexpected. I will double check the ranges because that shouldn't be possible. Oh, isn't the last student number like 9999999 as the last box?
67.
Oh, I will double check the student number boxes. Don't upload things yet. I'll check the labeling. The last two are the same, are they? Oh, then the name hasn't updated on the last one when I did it. That's the problem. So I will update the number on the last bin, and it should be okay. I'll do that as soon as I get back to my office. Yes? Yep. That's fine. Again, it's not. I'm hesitant to call it data, but it's fine to illustrate your examples. If your argument is some type of worker gets paid more in Sydney than in Canberra, and I work in Canberra, and I know people who work in Sydney in a similar job but get paid differently, then yeah, that would be an anecdote that you can use. It wouldn't. I don't want to call it data because data suggests it's systematic, whereas what you're doing isn't. But it's an observation that is useful to include, yes. And you don't have to quote a source, you just say, speaking to people, we found such and such. Does that answer your question? Yeah. Other issues? Cool. In that case, we'll get started on the content for the day. So, we're talking about economic growth, and we're going to talk about economic growth in terms of this aggregate production function. So we talked last week, the very end of last week, we talked about this aggregate production function, where we had income, which depends on the level of technology in society, the level of physical capital, and the level of effective labour. A few quick things to note. This level of effective labour is by combining number of labour hours, capital L, and average human capital. It gives us our effective capital, effective labour. Capital K is our physical capital, the room we're in, the computers we use, all that sort of stuff. And technology is everything that affects production that isn't physical capital, labour, or human capital. So it's all of our processes, basically, that make production more efficient. So A for technology is the everything else category. We also said, I will do this now, we also talked about a bunch of requirements on this function f, on what this function f looks like. In particular, we said that it's increasing in capital, that it's increasing in effective labour, and that it has diminishing marginal product in those things. And we gave an example of one that works, which is the Cobb-Douglas production, which looks like this. Sorry, that should be an H. Which looks like this, and that has the properties that we want. As we increase K, as physical capital increases, output does increase. As human capital, as effective labour increases, output increases, and it does so at a diminishing rate, because these powers here are less than 1. And people asked about graphing last week, but we couldn't because we didn't have a document camera. And so if we think about, say, capital against output, so let's fix H, and look at capital, let's fix H and A, and we look at capital versus income, then what we're looking at is basically y equals some constant, and k to the third. And so we need to know what k to the third looks like, and it looks like this. This is what y equals a k to the third. This is the kind of graph that this looks like. And you can see, hopefully pretty clearly, and again, this A is fixed, this H is fixed. You can see pretty clearly that we are increasing, as output increases as K gets bigger, but it increases at a decreasing rate. We're going to use this kind of graph a lot in the first part of today's talk. We could do the same thing with H. We don't typically, but you can. So you can talk about effective labour, right? If we fix K and A, we get the same thing. Because we get A naught, K naught to the third. This is just some number when we have fixed technology and fixed capital. And then we have H to the 2/3. And again, anything to the power of something between 0 and 1 is going to have this kind of general shape. We're not going to use this one as much today, or really at all today. But we're going to have this kind of general shape as well in human capital. It's just mathematically what this function looks like. Any issues, problems? Okay. So, for economic growth, we don't really ultimately care about the amount of growth. When you go to the media and people talk about economic growth, no one says the economy grew by, or not really anyone, says the economy grew by $10 billion this year. Right? That's just not a phrase that gets said very much, because it's not really what we care about. Because, for the same reason we care more about elasticities than sensitivities, it doesn't necessarily mean very much. If I tell you the economy of European country X grew by $10 billion last year, is that good growth or is that bad growth? Right? If the Vatican GDP grew by $10 billion last year, that's fantastic growth. If the French economy grew by $10 billion last year, that's terrible, terrible anemic growth. And so what we care about is the rate of growth. So we care about percentage changes. And that's what's always referred to. We always talk about China grew by 8% last year, France grew by 2% last year, Australia grew by 3%. So we care about growth rates. And this is our formula, as we're aware, this is our general formula for changes for the growth rate. Again, you multiply by 100 to make this a percentage. And so X is our variable of interest. Usually this is going to typically be something like income. Sorry, I should say growth. This is the amount today, the increase in the amount from yesterday, as a proportion of the amount yesterday. It's a standard notion of growth. Growth rates. So this is growth rate. X is the variable interest. This will usually, our variable interest will usually be income or income per capita. Really, it'll mostly actually be income per capita. Sometimes something like capital per capita might be of interest as well, but we'll see how we go. A quick note on notation. You probably have realized this as we've been going through, or hopefully you've realized this as we've gone through last week's lecture and things I've said today. We'll usually use uppercase letters for nominal amounts, total GDP or total amount of physical capital or total amount of labor. And we'll usually use lowercase letters for these sort of per capita amounts. We're actually going to be dividing by effective labor to get per capita amounts here. So we get lowercase y is income per person or GDP per person or per capita. Similarly for capital, similarly for human capital. Any questions? Questions, concerns, problems? Lovely. Okay, so now we can talk. Now we have the capacity to be able to talk about the Solow-Swan model. This is a growth model that was introduced in the 50s, in the mid-50s, which was simultaneously discovered or simultaneously developed by Robert Solow and, that's really bad, and Swan, Dr. Swan, which basically is a standard model in macro, standard base level model in macro from which we build most other models of economic growth or of macroeconomy in general. Again, this model is not meant to be the be-all and end-all. This model is a starting point from which we grow. If you have concerns with this model, that's good. It's because this model will have concerns with it. It has problems. It has lots and lots of simplifications because it's a starting point. And it's a good starting point, but it is a starting point. Okay, so going through the Solow-Swan model, it's a dynamic model, first of all, which means we're going to have time being involved. So that's why everything has subscript t's on it. Right? It's because we can talk about income at time t, income at time 1, income at time 2. Capital at time 1, capital at time 2. So it's a dynamic macroeconomic model. This model combines three key components. It combines an aggregate production function, and it in fact uses this Cobb-Douglas production function. We have a closed economy with no government. So we simplify away a lot of things. We get rid of the government, so there's no government spending. We get rid of net exports, so we just ignore those issues entirely. And so income is either consumption or investment. Built into this is the idea that investment and savings are the same thing, which we'll come to. And we have a notion of capital accumulation. So we have this idea that every period we make income, which we either spend or consume. Right, that's point 2. Every period we're making income Y, which we either spend or consume. Point 1 says every period we make income Y sub T. Point 2 says with that income Y sub T, we either consume it or we invest it into future capital. And point number 3 talks about how our stock of capital evolves over time. So capital is what we call a stock variable, because we think of it as we have a big pile of capital, and next period we have a similarly big pile of capital. Right? And the period after that we have a similarly big pile of capital. Whereas income, we really are thinking about income coming in and then going out every period. As I say, capital accumulates from investment. When we invest, that creates new capital. But also, very importantly, some of our old capital ceases to be useful. We have capital depreciation because old capital becomes unhelpful. Right? We talk about computers. A computer from 10 years ago is probably broken. And if it's not broken, it's probably pretty terrible. So capital depreciates over time. And we're going to go through all of these in more detail. So if you hold your questions on any of these until we've gone through them until we've gone through them in more detail. A few extra simplifying assumptions just to make our life easier. We're going to assume, well, I said that everything's dynamic. We're going to take away the dynamic nature of effective labor. We're just going to assume effective labor is fixed. So we're going to have that capital H, we drop the subscript and we have it fixed with time to keep life easy. It's very easy, it's not very easy, it's sufficient, it's not super difficult to extend this to allow H to change over time, but we're not going to. And, importantly, we're going to try and work all of this modeling in per capita values, which is slightly different to how the textbook does it, but not significantly different to how the textbook does it. I tend to think per capita values are the more important thing. It adds an extra step in our analysis, but it's not actually additionally difficult. Here I can do questions. Any questions on anything on the Solo model so far? Yep. Yes, we will definitely be thinking, I mean, so calling these three equations is also a bit of a misnomer because this first equation holds at every time period. So this first equation is really infinitely many equations, right? It's y1 equals a1 k1 to the third h1 to the third, and y2 equals a2 k2 to the third h2 to the third, and so on. So all of these, there's actually infinitely many equations here, but yes, we're thinking about these holding at the same time. One more time, sorry? We'll use the graph when we come to it. We'll see. We'll see. Otherwise, questions? Okay, so Solo model. The Solo model uses this, as I said, uses this Cobb-Douglas production function. The T subscripts are because the model is dynamic. And as I talked about sort of before we started talking about this production function satisfies all the properties that we wanted, right? It's increasing in capital, it's increasing in effective labor, but in both cases it's increasing at a decreasing rate. For those of you that don't believe me and have calculus, you can find the first derivative, the first partial derivative is positive, the second partial derivative is negative, is what gives this result. We do, however, want everything to be in per capita terms, and we're going to cheat a little bit and call H our per capita amounts. So we're going to divide everything by H and call that per capita. And we're going to see that in many ways actually makes our lives a lot easier, or makes things a lot neater and nicer. So we're going to divide everything by H, and we're going to see what happens. So we have YT we divide both sides of this production equation by H. Y sub T over H is just capital Y sub T divided by number of people, or effective labor, is just per capita. It's just income per capita. H to the 2/3 over H is H to the 1/3. Sorry, H is H to the minus 1/3, is 1 over H to the third. Well, H to the 2/3 divided by H to the 1 is 1 over H to the third because of the way exponents cancel. And so we can factor this like in this way. And K sub T over H is just capital per capita. And so it's lowercase k sub T to the third. And so this is really going to be our production function from now, for our per capita production function. Right, we have output per capita, really per effective capita, but I'm just going to say per capita, which is only in terms of technology and in terms of capital per capita. The reason I say this is nice is that when we draw our graph, basically the same graph as last time, but we think about capital per capita and output per capita, we no longer have to worry about the level of effective labor, because it doesn't appear in our equation at all, right? If we look at our equation, there just isn't any reference to human effective labor, sorry. And so we get the same sort of curve as before, where this is some initial level of technology, whatever it is, some level of technology, times k to the third. So we get the same sort of behavior as previously. This has a nice graph. Okay. And again, if we have all it's saying, low level of capital, low level of output, high level of capital, high level of output, but it's not proportional. If I double my capital, I don't double my output. I less than double my output. And I'm going to redraw this slightly so I can build on it. What I have was fine. I'm just Any questions? Questions, comments, problems? We just put it in per capita terms. Yep. Technology is just because, partly because technology is just the technology in the economy. There's no sense in which we would want to divide technology by number of people. Technology it's not like that. It doesn't divide across the individuals. It's just the level of technology in the economy. We could have used a lowercase letter for technology or an uppercase letter. It's not the kind of thing of income where you can talk about gross income or income per person, or gross capital or capital per person. There's just technology. Okay. Our next step is we have a closed economy with no government. So our usual GDP calculation, our usual way of talking about GDP is we have income is either consumption or investment or government spending or net exports, and we're going to just ignore government and we're going to ignore other countries. Again, you can extend the model to include government and to include other countries. It's not that hard, but we're going to not do that. We're just going to say closed economy. Closed means no external people, no imports, no exports. And we're going to ignore government as well. We then have this additional requirement that I should have made clearer as I go through this. I'm realizing I should have made clearer, which is that within our economy, savings and investment are the same thing, right? If an individual saves, the only thing that does, right, the thing that savings does is it becomes investment, right? The way investment gets money to create investment is by drawing from savings. Savings and investment are two sides of the same coin. Every piece of investment comes from savings, every piece of savings becomes investment. And so we have this idea of savings and investment are the same thing. And so we're going to talk about a savings rate. And so the savings rate is the proportion of income that is invested, or if you like, the proportion of income that is saved. So it's investment over output, or if you like, I prefer thinking of it in this way, but either way is fine. So we can talk about the amount of aggregate savings in the economy. And so if we wanted, we could talk about, so this is output per person, and we could equally talk about multiplying this by the level of savings in the economy. And so this is going to be, it's S over H, right? This is going to be savings. Savings per capita. There is no nice term for this because lowercase s is the savings rate. So the proportion of output that is saved. Again, to keep things simple, we're going to fix that savings rate over time. We're going to say that consumers save 10% of their income every period, regardless of anything else. Or they save 20%, whatever it is that they save. We are going to assume that the savings rate will be positive, which is not actually always the case, surprisingly. There was a little period pre-GFC when savings rates in a lot of developed countries, notably Australia, actually went slightly negative, which was not good, but that's neither here nor there. Any questions? Questions, comments? We have savings. We have output, we have savings. Which, again, savings and investment are the same thing. Okay, I shouldn't have drawn that yet. I should have waited a bit because I want to talk about it in terms of per capita terms. And again, I do the same sort of thing as previously. I divide everything by H. So I divide this equation here by H to get that output is either consumption per person or savings per person. And we get the savings rate is also in terms of this equation here, right? SY sub t, which is savings per person, is just total investment divided by number of people. Right, because this is also, no, I don't want to say that, do I? Yeah, I do. So we talk about this being savings per capita. Questions, comments, problems? Yes? This whole thing here is S sub yt, because this first part is y sub t, right? And this part is S. So this whole thing is SYT. Okay, and the last part of our system is capital depreciation. And so not all capital, so as I say, not all capital lasts forever. Each period, some proportion, in fact, all capital doesn't last forever. Each period, some proportion of existing capital depreciates, right? You have, often it'll be replaced, right? If we talk about this building, for example, this building is depreciating, but there is maintenance work done on it, which is a type of investment to keep it up to scratch. But the depreciation still exists. Right? Depreciation is just capital stops being helpful. So we're going to let delta be the proportion of capital that depreciates each period. We're going to think about capital depreciation being again, proportional. How much capital we have today, because capital is a stock variable, right? A computer doesn't, not all computers disappear, only some computers disappear each period. So it depends, so capital we have today depends on what we had yesterday, how much was depreciated from yesterday, and then investment also adds to our stock of capital. So we get that capital is what we had, capital today is what we had capital we had yesterday. We lose some of that to depreciation, but we gain some more through investment. And as before, we want everything to be in per capita terms because I think it's nicer. So we divide everything by h. This is where our assumption that h is constant in time becomes helpful. We divide everything by h. Again, k sub t over h is just little k sub t. Kt minus 1 over h is just k sub t minus 1. Delta is just delta times that, it's just delta times that. And this I over h is just s times little y because it over h is just s times little y. So we just divide by effective labor. And we rearrange slightly to put it in this form because we want to. So we have now capital per capita in terms of capital per capita last period and the saving and the level of savings per savings per capita this period, like the amount of investment that we put in to the model. Questions, comments, problems? Okay. So when we put everything in per capita terms, we get something looking more like this. This is quite nice because apart from this weird little part here, because we didn't have the notation, we've been able to basically, for the most part, get rid of effective labor from our modeling, which is quite nice. Now, the nice part here is that we can talk now about our dynamics in the model. So now is a good time for questions. If something's concerning for you, now is a good time to say it. Now is a good time to ask it before we talk about the dynamics of this model, because it is a dynamic model, right? We have all these subscript t's. Now we're going to try and use them. Yep. Yes. You'd be expected to remember the formulas, yeah. I mean, there's only realistically, there's you'll need to remember this because aggregate is aggregate production. You'll need to remember capital accumulation because it's the way capital accumulates. This one's more of an interim thing. We sort of use it to get rid of some variables, so it's not so important, but otherwise, yes. I shouldn't say that. You are not expected to remember them. You're expected to be able to work them out. Yes. Right, because this here just says, you're expected to remember Cobb-Douglas production and to know how to divide by h. You're expected to know what the capital accumulation is a longer one to remember, admittedly, but the capital accumulation hopefully to some extent makes sense. So I wouldn't say memorize, I would say understand. You would say, what does capital today look like? Well, it's clearly capital tomorrow, but then we get rid of depreciation, but then we add investment. How do we do that? Well, we do it this way. So I wouldn't say in many cases, with the exception of Cobb-Douglas production, which you do just kind of have to memorize, this one, in most cases it's not a matter of memorizing, it's a matter of understanding, I would say. I would not encourage you to try to memorize because you'll memorize it wrong. You want to try and understand what's happening. Questions otherwise? Yep. Consumption this is little c, so this is consumption per capita. So this already has been divided by h, if you like. I know it's actually harder to see if I write it down, but little c is capital C divided by h. English is really bad for little c and capital C, especially handwritten, because they look identical. Oh, sorry. H is effective labour, yeah. Yep, so it's effective labour every period. We assume that H is the same every period. Just to make our lives easy, we make an additional assumption that H doesn't change. So you can put a subscript T on, if you want to put a subscript T on it, that's fine. Just recognise that for our modelling purposes, we're assuming that H1 equals H2 equals H3 equals H4. Because of that, I'm just calling them all H. Okay, so the reason why we do this model is for the dynamics, because we have a dynamic model. So we want to think about what this model looks like in what we call our steady state. The model is in steady state when our output and our capital are not changing every period. So we're thinking about our model being in steady state when output is the same every period, same from one period to the next, when capital is the same from one period to the next. Now that happens, we get steady state when the capital today is equal to the capital yesterday. If the capital today is equal to the capital yesterday, then necessarily the income today is going to be equal to the income yesterday. So we get our nice steady state. And this is going to happen when depreciation is equal to savings. So there's lots of arguments why you can demonstrate this more directly. You can go through and work out and do some calculation and say, if I let KT equal KT minus 1, and I assume that this capital accumulation equation holds, then you pretty readily get to this idea that we have capital is in steady state when depreciation and savings are the same. Or depreciation and investment, because investment and savings, again, are the same thing. So we're looking for something where depreciation and savings are equal, and so we can go to our graph and we can draw the equation for depreciation. We can draw a depreciation equation, which is just delta times K, and so we get something like this. This is delta times K. Depreciation rate multiplied by the level of capital. And this is where our graph is really nice, because we can just go to our solar swan diagram, this is our solar diagram, and we can say, well, the level of capital that's going to make our economy be in steady state is going to be this level here. Right? This is the level of capital. Well, this is going to give us the level of capital where depreciation, delta times K, is equal to savings. And so this is, I'm going to call this K star, which is our steady state level of capital. We can talk about our steady state level of output. Our steady state level of output here. The point of all this is so that we can do some comparative statics and think about the kinds of things that we might try and do to encourage economic growth, particularly long-run economic growth. Any questions? Questions, comments, problems? Okay. Oh, yes, I do have this here. It is on this slide. So we can think about whether this steady state is in some sense a notion of a stable notion or an unstable notion. And fortunately, this is actually quite a nice stable notion. If depreciation is less than savings, so if we're in this area down here, right, if we have capital, if we have a low level of capital, right, a level below the steady state, well then depreciation is at this level here, but savings is at a higher level than that. So if we're at a really low level of if we're at a low level of capital, then we're going to be saving more than we are depreciating, or depreciating less than we're saving, if you like. And so we're going to see capital growing over time if we're in this world where we have low capital. Similarly, if we're in a world where we have high capital, then we're going to see then depreciation exceeds the rate of savings. Right? Depreciation's up here, savings down here. And so we're going to see capital, the total capital stock, shrinking over time. Or the capital stock per person, but same difference. Capital stock per person shrinking over time. So this is quite nicely, this is also a stable equilibrium. If for some reason we get a little bit of injection of extra capital, well, I say nice, it's nice and bad. If we get an injection of extra capital, then the Solow-Swan dynamics say that that capital stock is going to fall back down to the steady state. If for some reason some capital is destroyed, then we're going to see capital stock rising back up to that steady state level. And there are some fairly strong arguments in support of this kind of behavior, particularly when they were writing these works in the mid to late 50s. I think 56 is the year when these get published. This is what they will have observed. They will have observed, particularly this is sort of early post-war period. These authors will have observed that during the Second World War, huge amounts of capital were destroyed, and the more capital that was destroyed, the faster it was built back up again. Right? The faster the growth rate of capital was to build it back up. So as we get further and further, up to a point, further and further, more and more capital destroyed, the rate of capital growth and the rate of income growth gets higher and higher. So Germany particularly grew very, very quickly after the war. Japan particularly grew very, very quickly after the war. Russia to a lesser extent, but still, quickly. The countries that were really particularly devastated by the Second World War tended to grow very, very quickly in the post-war period. China's a bit of an unusual case because they had the continuation of the Civil War after the Second World War, and then some other things after that. So it's a bit of an unusual case in that respect, and certainly was not on the minds of the people making this model. Okay, questions, comments, concerns.
What now happens to our graph if we now consider government?
Consider what, sorry?
If we now consider government, it's not in a post-economy. Should that be the assumption with no government?
With the government, building the government in here is not especially difficult. Ideally you'd want to have, well, in the long run, you would expect the government to have neutral government spending, roughly speaking. Oh, that's not quite sure, is it? I'm not sure. I've not personally run through this model with government on it. So I can't say for certain what would happen with this model with government in it. I don't think it would be significantly different. And it'll depend on your assumptions about what government's doing as well. If government spending looks like consumption, in the sense of government spending is just the government spends money and it evaporates, then it'll be much the same. It'll be the same as this model, almost exactly.
So just to further confirm, as far as our model is concerned, we stick to the assumption that there should always be a close economy with no government.
For the modeling specifically, we're going to be thinking about no government, closed economy. Again, this is a base model from which you build. As I think on it, it's quite easy to build. Building government in depends entirely on how you think about what the government's doing. If government spending is like consumption, then there's literally no change to the model. Except the only change to the model is that we're going to, in a moment, interpret this level here as consumption per person. If there's a government, then this distance here will be a mixture of consumption and government spending per person. That would be the only difference. If you're thinking government spending has a non-consumption purpose, so government spending improves investment or something, then it will be trickier and you'll have to make allowances for that. But no, it's not that it's necessarily difficult to include a government here, to include a government sector here. It's that we choose not to keep things simple. That's okay? Okay. So, what we really want, what we almost really want anyway, is we want to increase the steady state output level. We want to cause economic growth to happen. Yep. 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 No. So the level of capital growth is this gap here, right? If we have this low level of capital, this gap here is the level of capital growth because it's the difference between savings and depreciation. As we have, if we're very, very, very close to having the steady state level, we have a very, very small amount of capital growth. If we're really far away, we have a very large amount of capital growth. That's all the argument that I'm making. It doesn't matter. It doesn't matter. It doesn't mean anything. There's no interpretation. It's when depreciation is equal to output. I guess that's all. Yeah. But it's not useful. So that question was what happens when the depreciation line crosses the output line, and the answer is depreciation is equal to output, but okay. Like it doesn't help, it doesn't mean anything. It doesn't have good interpretation. Okay, so we want to increase, we want to cause growth to happen in the long run. So we want to try to do things that push up that level of equilibrium, that level of steady state output per person or steady state capital per person. The main message that I've been ranting about, what this slide, is that just trying to accumulate capital is not going to be an effective method to cause long-run economic growth. Just capital accumulation doesn't actually help at all. Because if we just accumulate capital, right, go from K star to K upper bar, output will increase in the short run, but the dynamics of the system mean that depreciation will kick in, the extra capital we get will be sufficiently unproductive that the additional savings it produces is smaller than the additional depreciation that it causes. So we buy 10,000 new computers, right? With that, we're able to make enough money to make 500 new computers every year, but 1,000 extra computers depreciate every year. And so there's no point, right? We have the extra computers, it's nice in the short term, but it's not going to give us any sort of long-run economic growth. So the main message here is that capital accumulation on its own is not going to be sufficient. So we want to think about other options that we might look at. So the main option, or a main option, is technological progress. So this is to say we try and increase A, or to a lesser extent lowercase h, but we try and increase A. And if we increase A, then we get what we want. I don't want to draw too many graphs of this. I'll come back to this graph. I don't want to draw too many graphs of this. KY, delta K, right, depreciation. And we can say, well, when we have, this is our low level of output, this is our low level of technology. And we have a low level of steady state capital, right? This is our low level of steady state capital. K star naught. If we get more technology, right? I wanted to call this medium. I did want 3 of them. We can have a medium level of technology with a medium level, should be L, with a medium level of capital per person. We can have a high level of technology with a high level of output per person, with a high level of capital per capita. Too many colors. So as we see, as we increase our technology, we're getting a higher and higher level of capital per capita, steady state capital per capita. We're also, though I haven't drawn it on the graph here, we're also getting a higher and higher level of output per person. Right, so we're getting more and more higher and higher output per person. So technological progress is going to be, is realistically going to be the way we think about long-run economic growth within this Solow model, within the Solow model. There's not really going to be other ways that end up working for us. So Technological progress is going to be a good way of getting economic growth. We're going to call this a success. And when we talk about government policies to encourage growth, we're going to be thinking about technological progress as the government policy, as things that we can do to drive technological progress. Any questions, comments, concerns? Okay. We could talk about trying to decrease depreciation, right? If I could do something that would decrease depreciation, we have SYT. These should all have S's on them. All of these are meant to be interpreted in terms of having savings, right? Because we're thinking about steady states. So this is savings with a low technology level, savings with a medium technology level, savings with a high technology level. For those taking photos, again, I'm happy for you to take photos if you want. I strongly encourage you to write down the graphs yourself, because in an exam you have to write down the graphs yourself, and so it's good to practice. But I'm happy for you to do whatever it is that you want to do. Savings. We could think about decreasing depreciation, right? If we were to be able to go from a high depreciation rate to a low depreciation rate, that's good, that's great, right? We do definitely get the results that we want. We go from having a low steady state level, I'm going to call this K star H. We go from the K star that's associated with a high depreciation rate to a steady state K star L. The steady state associated with a low depreciation rate is certainly a larger level of, or a greater level of capital per capita. Right, so if we decrease the depreciation rate, we push up that level of capital per capita. Can anyone think of ways we might decrease depreciation rates? Good. That is, in fact, the problem with this idea, is that we really don't have a good way of decreasing depreciation rates. Depreciation rates are what they are. They're an exogenous thing in our model. From a policy framework, they're an exogenous thing. We really don't have anything that we can even possibly do to push down the depreciation rate. So while it would work, while it would be great, in practice we can't really do this. Or to do it requires you to spend more on the capital initially, which is the same thing as saying that you're just making more capital. Okay, the other option, the final option I want to talk about is I want to think about what happens if I increase the savings rate. And the savings rate one is the one that I find most interesting. Here we get a new graph for it. So we think about what happens as we increase the savings rate. S1 AK to the third. S2 A K to the third. So S1 is our low rate of savings, S2 is our higher rate of savings. And this looks promising. This is our depreciation line. This looks promising, right? We get long-run growth. We go from having I'm going to call it long-run growth. We go from having K star 1, right, the level of capital associated with a low level of savings, to a new steady-state equilibrium where we have a higher level of capital per capita. So by increasing the savings rate, we increase the amount of the capital density. That's not the right word. We increase the amount of capital per capita. There's a problem here, and so therefore we increase the output. Right? We have more capital, so we have higher output. There's a problem. There is nonetheless a problem here. Can anyone? I mean, this is sort of a stretch. It's on the next slide. Can anyone think what the problem with doing this might be? As a way of driving, I mean, not so much as a way of driving economic growth, but certainly as a way of driving economic well-being. There's more stuff, right? We're producing more stuff every period in steady state. Pardon? Yes, we're producing more stuff, but we're also saving more. So it's not really clear whether our people are actually being better off in the form of having increased consumption. Maybe they are, but maybe they're not, right? Output per person has gone up, but savings per person has also gone up, so consumption might have gone up, but it might have gone down, right? We don't really care that much about production. If we're thinking about well-being, at least, we don't really care about production. Production is lovely, but it's not the main thing we actually care about. We actually care about consumption per person, because that's what's going to be driving well-being. The fact that there's lots of investment in the economy doesn't help me. The fact that I have lots of consumption helps me. So we care about consumption per person. And so we need, in addition to these savings graphs, we also need the output graph. Right, so this is just output per person. And we can think about how much consumption is. Consumption is going to be our gap. Consumption per person is going to be the gap between output per person and savings per person. So it's going to be this gap here between output and savings per person. So this distance here, this is the consumption associated with the lower level of savings, right? We have relatively low output, but we consume a huge portion of it. By contrast, if we have this higher level of savings, just graphically, just the way I've drawn this, with this higher level of savings, we actually have a smaller level of consumption. We have a lower level of consumption because there's a lot more out there in the economy, a lot more production happening, but we're having to save so much of our money to retain that level of capital that we're actually worse off as individuals. We have lower consumption as individuals. So higher savings rate might be good, it might be bad, it's very, very unclear. There certainly will be and you can go to extremes, right? If we have 0% savings, then then everything is terrible because we immediately drop down to zero we drop down eventually. We steady state at zero capital, and we have zero output, which means zero consumption. So a rate of savings of 0 is terrible. So we end up with a steady state of no output, no consumption. Savings rate of 100% is equally terrible because we end up with masses of capital and masses of production, but we're saving all of our money just to keep our capital going, just to keep our capital stock in place, and so we end up consuming nothing. So we get zero consumption. So the extremes are really bad. And so there's going to be some point in the middle which is the optimal point. And you can actually go through some mathematics and show that there is a unique optimal point. And we're going to call that level of savings the golden rate of savings. Graphically, looking at this graph, it's actually very nearly S1, I think, here. Graphically, it's going to be the maximum. No, it's going to be a little bit lower. It's going to be the thing that maximizes. Yeah, I do need that. Graphically, I'm going to use a new graph. I'm going to use a new graph because I can. In the steady state, savings and depreciation are the same thing, right? In the steady state, saving and depreciation is the same thing. So in the steady state, as we saw here, I will actually show this quickly. As we saw here, in the steady states, consumption was the gap between output and depreciation, right? Was consumption in our steady states. And so more generally, if I'm thinking about what's going to be the savings rate that maximizes consumption, it's going to be the level of savings which maximizes the gap between output and depreciation. And so just eyeballing it, I reckon it's something like, it'll be where these are parallel, so it'll be about there. It's about here. It's about here. Eyeballing it, it's about here. It's going to maximize the gap between output and depreciation. And so this is sort of I'm going to call it CG actually, for the golden rate, right? Which means this here, this is S sub G, times YT. It's the golden rate of savings. Or times, yeah, YT is fine. This is the amount of capital that we have at the golden rate level. Oh, I don't use that. I got rid of that as notation. Oh well. This is going to be the golden rate of savings. It's going to be the level of savings which makes this capital, makes this consumption per person as large as possible. And there is a unique level there. Right? Having more savings beyond that makes people worse off. Having less savings below this also makes people worse off. This is going to be our optimal level of savings to make individuals as well off as possible. And there is a unique value there. Take home here being more savings and more capital might be good, but it might not be good. It's unclear. Yes. Yeah, we're still assuming technology. When we're doing this analysis, we're assuming technology is equal and yeah, all that kind of stuff. I don't think it'll, I'm not going to say that because I don't know if that's true or not. Yes, we're assuming everything else is held equal. Yeah, I mean, I'm happy just to say we eyeball it, but yes, the way you do it is this point, this is the level of capital at which these lines have the same slope. As which, yeah, so the tangent line here is parallel to delta K. Yes. Ultimately, but it's not important for now. So again, main messages, increase in the savings rate, kind of okay, but there is a golden rate of savings that maximizes our consumption per person. Decreasing depreciation would be nice, but we can't really do it. Increasing technology is going to be really the way to move forward here. As I said earlier, there's a huge literature extending this model. The original model was already a bit different to what we have here. The original model was in continuous time. It had only exogenous changes to effective labor. It didn't have this notion of technology. It sort of bundled capital A, technology and human capital into one object. So it didn't have a technology notion A. There are other models. The Roma model really builds human capital more explicitly and talks about it in a more substantive way than we have. The Ramsey-Cass-Koopmans model takes that savings rate and allows it to change over time and allows consumers to choose the savings rate each period. So it gives intertemporal incentives, and it's much more difficult. It gives intertemporal incentives and it allows consumers to choose the savings rate each period. So it changes over time. But again, all of these models start from the Solow-Swan model, or the Solow model, and they modify that to include things that they think are important or interesting. So one modification we might do is include government. And you have to decide how you include government. You might talk about human capital more significantly. You might worry about the fact that we're making the savings rate constant and think maybe the savings rate should be able to vary over time. So there's lots of stuff that we can do here. Okay. Questions on any of this? This is the last of the modeling, and then we talk about policy. We'll have a short break and then talk about policy. Questions, issues? Lovely. In that case, we'll have a quick break. This is an annoying time. We'll have like a 4-minute break. So I'll start again at 17. I'll have a 3-minute break, starting at 17 past the hour, just to sort of stand up and stretch your legs. I'll see you all in a couple minutes. Okay, it's about 19 past, so we will get started back again. So, I want to talk a little bit about government policy, and then hopefully we'll also get some time to talk about unemployment, because these were the slow slides we just finished up here. So, given what we've just talked about, we want to think about government policies that might encourage economic growth. And there's a few that I've sort of listed here that we can think about when we're approaching this problem of encouraging economic growth. And we'll go through them. We'll go through them gradually. So, we could think about encouraging savings. And it's in the text, like it's part of the textbook, and it is something that the government can do, and it's something the government does do, which is part of why I'm including it here, is the government does go out and encourage savings. Certainly this will increase steady-state production. The question of whether this increases steady-state well-being is much more difficult. It depends on whether our savings rate is low, but too low, lower than the golden rate, or too high, higher than the golden rate. If we're already saving too much, then extra savings is going to make us worse off. Even in the long run, it's going to make us worse off. If we're not saving enough, then saving more is going to make us better off in the long run. So when the government is going out and encouraging savings, it's hopefully at least, because the government thinks that the current rate of savings in the economy is below that golden rate. And I can't tell you what that golden rate is. Right? The average rate of savings is usually around about 10%, which I believe, from my understanding, is pretty close to the golden rate. But it depends on so many parameters that I just don't have access to. Certainly, in either case, if we bump up the savings rate, in the short run, there's a decrease in well-being. Right? So if we bump up the savings rate, I wanted to save this graph. If we bump up the savings rate to a higher level here, right, S prime to a higher level, there's an immediate effect. And the immediate effect is that we go from getting consumption, so much for this graph, we go from getting consumption C1 to getting consumption C2, right? We have an immediate reduction in consumption. In the long run, this is going to become better. We're going to get better than C2 because we end up here. And in the long run, we get C3 consumption. But in the short run, regardless of whether we have too little savings currently or too much savings currently, there's going to be a short-run hit because it takes time to accumulate the capital, but the hit to consumption due to the increased savings happens immediately. The way the government goes, well, one of the key ways the government uses to encourage savings is through the interest rate, and we'll talk more about that later in subsequent weeks. If I'd drawn this properly, I believe C3 is necessarily larger. Yes. If I had drawn this properly, then C3 is strictly larger than C2. The fact that it looks like C3 might be smaller or the same size is because I've drawn the picture poorly. Theoretically, it is necessarily the case that C3 is bigger than C2. But there's no reason to think that C3 might be bigger than C1. Would it be bigger or smaller than C1? It might be, but it might not be. So encouraging savings is fine if we don't currently have enough savings, but it only works in that circumstance. Otherwise, it actually makes people worse off. Questions, comments? Okay. Some other things that we can talk about. This is a little bit outside our model, but we can still talk about it in light of our model. We could talk about overseas investment. Again, this is outside our model because our model blocked off the external economy, but that's okay. So we can talk about trying to get funds from external investment, which will increase output because there's then more capital. It will potentially only, if it's only a one-off hit of outside funds, it will potentially only increase output temporarily because of the dynamics we talked about earlier. Because of the dynamics we talked about earlier, where having too much capital just brings us back to the steady state level. But if it's an ongoing thing of continuous external investment, then we potentially can end up with just a steady state, a higher continuous level of output and consumption per person. The main reason I bring this up is to introduce some terms, because they're terms that you should know you should have seen these terms before, which is foreign direct investment and foreign portfolio investment. Foreign direct investment is I open a factory in Vietnam. Foreign portfolio investment is I invest in Tencent, right? The Chinese company Tencent, or whichever company, or Huawei or something, right? I invest in Huawei, in shares in Huawei. So we can talk about foreign capital investment or foreign direct investment or foreign portfolio investment, both of which are types of foreign investment. It's just different types, and they're treated differently. And as I say here, just to sort of talk about this a little bit, foreign countries invest because they expect a profit, because they expect return on their investment. So if you're in a situation where you're not expecting a return on your investment, obviously you're not going to invest. So this is part of why you don't see a lot of why it's hard to get foreign direct investment, particularly in a lot of countries in Africa, a lot of sub-Saharan African countries. It's hard to get foreign direct investment because it's not clear that you're going to be able to get a return on that investment. So anyway, overseas investment, and it can also serve as a way to kickstart your economy. If you are a poor economy and you're sort of languishing down with low levels of capital for some reason, then foreign direct investment can kickstart that. So this is down here. This is Australia in 1820. Tons of we simply can't produce enough stuff to increase our capital stock up to the steady state fast enough, and so we take in lots of foreign direct investment to drive that growth very, very quickly. This is also places like Australia in 1820. We can talk about Germany or most of Europe really, most of Western Europe in 1946, 47, let's say. So the Americans had the Marshall Plan, where they sent huge amounts of money of foreign investment into Western Europe, because Western Europe was way, way down, super low levels of capital, and so there was benefit to investing in those countries at that time. Questions on foreign investment, overseas investment, or foreign investment? Okay. We can talk about education. So in our Solow model, increasing education pushes that average human capital level up. That's going to be the way we talk about this. It's a little hard to analyze given the modeling that we use because we divide everything by capital H. But I do want to argue it's going to increase well-being. We do get increases in at least output divided by labor hours, so the output literally per person, if not per effective person. So I don't want to talk about this too much in terms of our modeling, because our modeling kind of obscures the effect of education. But certainly increasing education increases output per person, and it increases output per person in the steady state. We still exhibit diminishing returns here, because if we look at our original production function, we do still have, if we look at our original production function, which I'll just write down rather than try and find. We do still have diminishing marginal product. We still have that little h here is to a power that's less than 1. So we need to be a little bit careful. And this is not surprising, right? If you teach someone to read, the benefit to their productivity is enormous. I mean, enormous. If you teach someone to be able to do basic arithmetic, the improvement to productivity is enormous. If you teach someone this is primary school. If you teach someone how to do literary analysis or calculus or algebra, it's still good, but it's not as good as it was to teach them to read and do sums, right? And do arithmetic. If you teach them university courses, it's good, right? It still improves productivity, but it doesn't improve productivity by as much as what was able to be done in high school, which was itself not as much as the benefit that was gained from primary school. So we do still get these diminishing returns. There are returns, but there are diminishing returns. It's still potentially useful here. There are potential, again, well outside our model, there are potentially positive externalities associated with increased education. You tend to be, there are positive externalities, right? Having an educated populace outside of the benefits to the economy, having an educated populace also has benefits to society. And so there are these positive externalities as well. Something I do want to talk about, and I don't want to talk too much about the positive externalities. Something I do want to mention, because I think it's relevant, particularly in development economics, is this notion of the brain drain effect. Has anyone heard of the brain drain effect? Brain drain. Who's heard of brain drain? A couple over there. Wow, that is much, much less than I would have anticipated. The idea of brain drain really applies, it applies mostly to developing economies. And so if you're, the issue, let's talk again about sub-Saharan Africa as developing economies, still quite poor economies. If you're the really, really smart kid from your village, and the village bands together and sends you to university in, let's say, in Australia, then there's a couple of ways this can go. This can go as you went to Australia, got even higher education, and went back to your village and provided significant benefits to the village. Or you might be the really smart kid from the village, you go to the university in Australia, and then you stay in Australia. And the really smart kid from that village no longer lives in that village, right? They're no longer even providing the benefits even of a high school educated individual in that village because they live in Australia now. This is what we call the brain drain. The brain drain is this effect of highly skilled individuals leaving the country to live to work elsewhere because they can get a higher rate of pay, but also a greater well-being living in Australia or America than they can living in whichever country, the sub-Saharan African country that they come from. So there's this brain drain effect. Brain drain affects developing countries. It also affects developed countries. Places like Australia have brain drain effects, where, particularly in the physical sciences, we produce a huge number of physical science graduates, a lot of whom then move to the US, where there's more jobs. And so we take the really highly skilled workers, highly skilled individuals, highly trained individuals that we've spent lots of time and energy training, and then they move overseas because the jobs don't necessarily exist in Australia. This is not really as much of a concern for accounting and finance and business. This is really more for physics and chemistry and biology. But it's still a brain drain effect. In a place like Australia, that's where the effect happens. But this brain drain effect is still going to be significant in a lot of places. Australia benefits, but also has costs. America mostly benefits. Lots of places just have downsides from this. Questions on education or brain drain, the notion of the brain drain effect, because the brains drain out of the economy, out of the society.
Is that a short run with brain drain? I understand that some economies, they go away, experience and work in the world, and they come back to their orbit.
Right, so people who come back, then we would then not call, you wouldn't worry as much about it as a brain drain issue. It's really people who move away and don't come back, which, as I say, is not at all uncommon. And even moving away temporarily, depending on the extent to which you're gaining skills overseas versus just living overseas, you would still talk about it to a lesser extent as a brain drain issue. Right? If I live and work in New York for 10 years, that's 10 years that I'm not living and working in Australia as a high-skilled, highly trained individual. So you still have the same effect, but to a lesser extent if you move back. I've not heard the term orbiting before. That's a good term for it, though. Questions on education? Okay. Health and nutrition. This is an actual point here. Yes, encourage health and nutrition. Again, this is a little bit maybe outside our model, but not quite. All else equal, a healthier workforce is more productive. If we would try and include health and nutrition into our model, we would probably put it either in technology A, into our catch-all A, or you could make a strong argument for putting it as part of human capital, because our workers are, human capital is really skills, education, training. So you could you could argue that it's part of human capital, how healthy the worker is. I think the textbook argues that it's part of human capital. I would think it's more like part of our catch-all technology field. It's really sort of an argument question here. But obviously the argument I want to make is health, whatever it is, however it does it, health increases output, right? Healthier workers are more productive workers. We also have this nice, what we might talk about as a virtuous cycle. Healthier workers are more productive. That means there's more production, which means we have more production that we can use to spend on increasing health outcomes, which makes healthier workers, which increases productivity, which increases production, which means we can spend more production making healthier workers. So you get this really nice virtuous cycle. Right? Rich countries are rich partly because they have healthy workforces, and they have healthy workforces partly because they're rich. This is starting to break down a little bit, particularly in Australia and America, notably, where rich society, where that correlation is starting to break down a little bit because we have obesity issues. Is that you get very, very wealthy, you start to have obesity issues, which reduces health outcomes. So you need to be careful. There's not a strict, I'm not saying there's a strict correlation between health and productivity, between between production and health, but there is a correlation here, which is breaking down at the higher ends, or you need to be careful with at the higher ends. Questions, comments? Excellent. Oh, this is the big one. Political stability. This is the one that I'm going to talk about as the biggie. Realistic, at the end of the day, the key thing. These are all things that are good to have. You know, savings, fine. Education, yeah, education definitely good. Health and nutrition, yeah, it's good. But political stability is really the thing that allows the entire structure to function. And we're going to fold all of our political stability stuff into that notion of technology, because technology is everything else that's not physical capital or human capital or labor. So it really falls into that technology field. In order to have long-run growth, we need enforceable contracts. We need to be able to have a situation where I can sign a piece of paper with the university that says that they'll hire me for X number of years to do such and such a job. The university needs to know that I'm not going to rip them off, and more importantly, I need to know the university is not going to rip me off. Right? We need to be able to have enforceable contracts. When we're building the light rail, we need to be able to sign a piece of paper that says the ACT government will pay such and such money at completion to the firm, and the firm will finish the project. And the firm says they'll finish the project. And both parties need to know that that both parties are going to follow through on that contract. And so we need enforceable contracts. If you try and break the contract, this is the punishment. To be able to do that, we need strong rule of law, so that the government doesn't just say, oh yeah, I did sign that, but I'm just not going to pay you because I don't feel like it. Right, so you need the rule of law to be able to stop that kind of thing from happening. This is going to be one of the key things here. So we need rule of law, enforceable contracts to drive that long-run growth, to drive growth at all, any kind of growth. This is going to be what's lacking in a lot of the developing countries that aren't growing. What we're lacking is the rule of law and enforceable contracts. It's helpful to have a notion of economic certainty. Again, if there's a revolution in your country every 5 years, then no one's going to invest, because if you invest stuff, then you know that in 5 years' time, the government's going to appropriate it in the next revolution. Right? So why would you bother investing? So economic certainty is going to be very, very helpful, because otherwise there's no point saving, because there's going to be a revolution anyway, there's going to be massive inflation anyway, there's going to be huge problems regardless, so why would I bother trying to save for 5 years' time when it's going to be taken from me anyway? So economic certainty for investing. This is also at a more basic level. This is an ambiguity aversion type of thing. What I do in my own research is ambiguity aversion. This is an ambiguity aversion type thing. If you know that the economy, like if you're trying to invest in Australia, you kind of know that the economy is going to grow probably between 2 and 4%, or probably between 1 and 4%. Maybe there'll be a recession, it'll shrink at 2%, it'll shrink by, minus 2% per year, or minus 3% per year maybe. But your boundaries are like minus 3% in the case of a devastating recession to like 4% if everything goes perfectly. And that's not a huge range, right? If you're investing in the economy generally, it's either going to grow 4% at best, shrink 3% at worst. That's okay. It's a relatively narrow, you have a certain degree of economic certainty. If you're investing in Venezuela, right, maybe the oil price will quadruple in the next 5 years, and Venezuela will go back to being stable and fantastic and making huge amounts of money, and will grow at 20% per year for the next 5 years. maybe that won't happen, and the oil price will continue to drop, and Venezuela will fall further into civil war or coup, or I'm not going to try and make claims on what's happening in Venezuela at the moment. It's not good, but I'm not going to make claims on what's happening there at the moment. And you'll actually shrink, and your investment will shrink by half every year, right? And so your range goes from minus 50% to plus 20%, and you have this huge range of possible outcomes. And so even if the expected value increases, you don't want to invest in it because the risk is so very, very large. So economic certainty helps because it mitigates risk, right? Knowing that the economy is minus 3 to 4%, that's not too bad. We want to have lack of corruption. Again, this falls a little bit under this rule of law and enforceable contracts argument. If there's lots of corruption in your society, then you're not going to have strong rule of law. It's like, yes, I agreed with the government that I would do this, but actually it turns out the person I agreed with was horribly corrupt and took a bunch of money, extra money, or whatever happened. I was looking to invest in some farmland in Australia, but actually to get that farmland, you have to know the person in charge of the water department or the agriculture department, and I don't know that person. And so the corruption the corruption stops growth from happening. So you want to have lack of corruption. You want to have property rights for innovation. I don't have things this, do I know? You want to have property rights for innovation particularly. So this is this idea of you want to have a situation where if I invent something, I'm able to protect that invention. I'm able to make money off that. And that means that I have an incentive to create the invention in the first place. That gives me an additional incentive, I should say, to create the invention in the first place. This is really tricky, this one. Do I have this later? Yes, I have this later. I'll come back to property rights for innovation in a moment. But this is our notion of copyright and patents and those things here. So I invent a new drug, which helps with nausea. I invent a new nausea medication. I can make money off that for a certain amount of time because I have intellectual property protection. And the fact that I have that protection means that the drug is more expensive. It means no one can use my drug to develop new drugs for a little while, which is bad. But if I didn't have that protection, I would not want to make the drug in the first place. So property rights for innovation encourage that innovation to happen, make it more difficult to innovate, but give incentives to try to innovate, which I'll come back to on the next slide. Again, this rule of law is going to be super important because we need market formation to happen. If we're thinking about trying to encourage economic growth, we need to be able to form these markets. And the rule of law helps that to happen. If there's no rule of law, why would you buy an apple from me when you can just take an apple from me? If any apple I make is just going to be taken from me, why would I grow apples? Yeah? So in order to have that market, to be able to sell things, we need the rule of law so that I can have things that I have that I sell to you in order to get money from you or get something back from you. So we need that. We need markets to form. All of these ideas are what we call institutions. So if you see people talk about having strong institutions, that's all of these sorts of things. It's other things as well, right? It's more explicitly institutional things. An independent central bank, a strong judiciary, an independent judiciary are all institutions as well. But these basic things like economic certainty, rule of law particularly, property rights for innovation, these are all examples. That's the time? Damn it. These are all examples of institutions. Any questions so far? Again, I'll come back to property rights on the next slide. But any questions at this time on political stability? Again, part of this is don't have a coup every 5 years, but it goes beyond that as well. Okay. So, we said technology growth was the factor driving long-run growth, and so we should talk about ways to improve technology in the usual sense of the word technology. And in the usual sense, which is part of our sense of the word technology, we want to think about research and development. So research and development is just spending on research and development, spending on creating new ideas or implementing those new ideas. We can talk about public expenditure and also private expenditure. Given that there are very, very large positive externalities associated with R&D research, research and development, R&D, I say here many, I'm going to go further and say most economists suggest government should subsidize R&D. Most suggest government should subsidize R&D pretty heavily, and most governments do subsidize R&D. Right? Governments pay partially for universities. They pay for, in Australia, we have CSIRO, which is the government-funded body that creates research and development. Patent systems and copyright systems are designed to encourage private sector innovation. They are important, right? They are incredibly useful to encourage private sector innovation. However, they are tricky. And this is where I want to talk, this is where I wanted to be careful. I want to be careful with my language here. It has been suggested, right? So this is our notion of benefit. This is our notion of benefit, and this is our notion of level of protection. I shouldn't write like this, should I? Sorry. Oh well. It's done now. This is benefit. This says benefit. This says level of protection. So there's the benefit versus the level of intellectual property protection that we can have. If there is absolutely no intellectual property protection, then there's no monetary incentive to develop new technologies, right? Because when I develop new technology, it immediately is used by everyone. I can't sell it because I can't protect it, and so there's no monetary incentive. There might be other incentives, but there might be other incentives, right? I may just want to develop technology. Lots of people make programs online that increase technology without being requiring to be paid for them. The big example that we use is the vaccine for it's the polio vaccine. The polio vaccine was developed and then immediately made free, was not patented. The person made it and then was just like, yeah, this is great. Everyone, take the vaccine because it's fantastic. And so there's definitely some benefit when we have no protection at all. There's definitely some benefit to protection, to some level of protection, right? Some additional benefit to protecting intellectual property. Again, the downside of putting in protection, there's an upside and a downside. The downside of putting in protections to intellectual property is that I develop a new drug, but no one can see what this drug, how I've made this drug, and so no one can improve upon the drug that I've made. And also, because I have the sole ownership of that drug, I'm going to be charging a lot more money than the marginal cost for that, right? Because I'm going to be the monopolist producer. So I'm going to be producing a lot less than the social optimum. The upside of having intellectual property protections is because I know that I'm going to have a monopoly for a certain amount of time, it encourages me to want to produce more of the good, to want to produce more novel items, to want to produce more drugs and more novel drugs, because I can make money off them. So there's pros and cons to protection. And broadly speaking, for very low levels of protection, the pros become really helpful and the cons are not that important. And so for low levels of protection, we tend to see benefit increasing, and that's all good. And then at a certain level of protection, these things even out, and we start to get worse. And we start to get worse. Right? We start to get the benefit of the benefits from innovation start to shrink, because they're so restrictive, right? If I can never see anything, if I never have any idea what goes into any drugs ever, right? Super extreme level, then I'm never moving beyond like second century medicine because I don't know how anything works, right? This is terrible. This is terrible. This is much worse than than having no protection at all. And so the question is, where on this graph do we currently lie? And there is non-trivial suggestion that we currently lie somewhere out here. Look at us. That the current level of intellectual property protection is somewhere way out here. Right? Somewhere where the level of protection is so restrictive that we'd actually be better off having no protection of any kind. Right? There's an optimal level. Right, L star, there's an optimal level of protection, which maximizes the benefit to society. But where we are now, it has been argued that where we are now is so restrictive that it's worse than nothing. Right? There's something that's better than nothing, but where we are is so restrictive it's worse than nothing. Any questions? Yes? Do positive externality, negative externality still hold for aggregate levels? You don't talk about positive externalities and negative externalities as much. I know I have a little bit, but from a modeling perspective, we don't really talk too much about positive externalities and negative externalities. That's all I can really say here. Yeah. It should, in principle, be built in because there's no external thing to the world. There's just output. So I guess it should be built in. Into technology, for example, maybe. The monopoly is, for R&D purposes, the monopoly, we allow monopoly because if we don't allow monopoly for a little while, then there's no financial incentive to produce innovation. The monopoly produces the financial incentive to encourage innovation, which is a plus. The downside is we have a monopoly, which has deadweight loss. So it's a balancing act between how long do you allow people to hold these monopolies. Okay, what have I got left? Okay. Any other questions? Okay. I'll talk quickly because we've only got 4 minutes left, so we won't talk at length about unemployment, unfortunately. I'll talk quickly about some older hypotheses for why. So, if we look around the world, we see that there is a divergence in output levels per capita. Right? We saw way back in Monday of last week that there is differences in output levels between countries, and so we want to look at some hypotheses for why that might be the case. We're going to look mostly at old hypotheses. Mostly at fairly old hypotheses. One hypothesis is what we call the geography hypothesis, which is that different countries have different output because they have different geographies. Differences in geography, climate, and ecology are responsible for the differences in economic outcomes. If you read the way people used to talk about this, it was quite racist. It was really like people who live in, it was very much Africans and Asians don't have the right skills to be productive kind of thing. This is back in the 50s and 40s, or earlier than that. But there are reasonable arguments that go towards a geography hypothesis, which is that if you look at wet temperate areas, then, for example, agriculture is a lot easier in wet temperate areas. If you have a country where it's easy to grow food, where it's easy to perform agriculture, then that country has the capacity to have a higher level of output per capita. If you look at places where there's lots of desert, then you're going to see agriculture being very, very difficult, and so you would potentially argue that there might be lower potential output per capita due to the geography. Or areas that are particularly mountainous, you can't get good transport links, for example, in mountainous areas, might cause some problems. Even so, it's not a very common hypothesis for the difference, and it leaves a lot of things unexplained. Particularly, Singapore is just such a good counterexample to all of these kinds of older arguments, because Singapore is a tiny country that has basically no land for agriculture. It does have some agriculture, I'm aware, but virtually no land for agriculture. It's swampy in the middle parts, or jungly. It's either jungle or swamp in most of the middle parts. And yet it is a country with a very, very high output per capita. So certainly the geography hypothesis might give some insight, but it doesn't give a whole lot of insight into why these differences occur. We can talk about the culture hypothesis. Again, another old claim here that different values and cultural beliefs drive differences in prosperity. This tends to be more overtly bigoted or overtly racist than the geography argument. We don't really want to talk about this. People don't talk about this really anymore. It's in the textbook. The textbook is much more forgiving of this argument, I think, than I am. The textbook really takes a historical view, whereas I'm happy to take the view of this is an argument people used to use, and those people were basically wrong. And so but it is an argument that people make for the differences. Yes. The standard arguments now are basically are mostly a matter of historical accident. The standard argument now, which I didn't put on the slide for some reason, is the argument that I would make is an argument from historical accident. Places like Britain are rich because historically they've been rich for the last few hundred years. Places like Nigeria are not particularly wealthy because they've never been particularly wealthy, and so they remain not particularly wealthy. With the last time that's over time, I do want to mention here that economic growth, as I've talked about earlier, economic growth is not everything. One of the reasons why is because of poverty. So rapid increases in GDP are often, though not always, associated with increases in inequality. Actually, what we have here is the opposite on this. That's interesting, isn't it? It is said that rapid increases in GDP can be associated... Oh, here we go, yes. Rapid increases in GDP are often associated with increases in inequality within the country, but also